How's it going, everyone? In today's video, we're going to learn about 5 good Python habits that will help you create beautiful and maintainable functions in Python. For today's tutorial, we will be using Z as the code editor. If you'd like to try Z, I've left a download link in the description box down below. Let's get started with the first habit, which is specifying a return type for your functions. As many of you are aware of, Python does not require you to explicitly type anything. It will literally just roll with whatever you tell it to do, which usually means lots of bugs and errors. One way to minimize the chance of these bugs and errors is by explicitly telling Python what you expect a function to return. That way, if you make a typo or accidentally return the wrong type, the static type checker will help you out so you can fix it before running your code. For this example, suppose you're writing a function that should return a string, and for whatever reason, you end up returning an integer. This example is oversimplified, but in a real function this can easily happen. When you use the function, it might work just fine, but that doesn't mean it's working as expected. When we wrote this function, we said that it should return a string, and yet we returned an integer by mistake. Watch what happens when we try to use the function we wrote in string concatenation. So here we're going to create a variable called combined, which is going to equal readApple plus text. Then we're going to print combined. And as an output, we're going to get a type error, which tells us that we cannot concatenate an integer and a string. So we ended up with an error, even if all the code we wrote was perfectly valid. This means we're going to have to waste more time looking for the error in our logic, and no one's going to help us find it. We will need to manually look at every single line of code we wrote to identify the problem. The solution here is to specify the return type explicitly. This will help your code editor understand what you're trying to do, meaning that if you return a different type, it will warn you immediately. Now, the error is very easy to spot thanks to the return type, and we don't even have to run the code to find out about it. So here we can return string of var. And now the next time we run this, it's going to run correctly. And if your function isn't meant to return anything, you can specify none as a return type. Again, it helps with communicating the intent of your function. And since we specified that this function shouldn't return anything, the static type checker will complain if we try to return anything that's not none. As you can see here, we told Python that we want to return none, and yet we returned a string. It's important to note though that type annotations don't prevent your code from running. They just give us really nice insights on the trash code we wrote so far. Moving on to good habit number 2. As we just learned, we could specify a return type for any function. But something else that I absolutely recommend is specifying parameter types, which helps narrow which types are accepted by a function without introducing a bunch of isInstance checks. For this example, I'm going to create a function called combine as int. And what it's going to do is take a and b and calculate the sum and return the integer version of it. Right now, our function will allow us to insert any type we want as arguments for a and b. But that's pretty silly since we might try to insert types that don't really work with our logic. And unless we read the function, we will not know that it was a mistake until we run our code. Right now, if we try to run this, we will end up with a value error, because it's kind of hard to convert the sum of a plus b to an integer. Otherwise, if we insert some numbers like floats or integers, it's going to work as expected. But again, it would be nice to get some sort of warning when we insert an incompatible type. So a better approach would be to specify the types of a and b so we can see our mistake immediately. So here I will specify that a should be of type float and b should be of type float. We're using the float type here because it covers both the int type and the float type. This means we can insert both integers and floats, and the static type checker will be fine with that. But as soon as we try to insert an incompatible type, the static type checker will tell us, hey, you're inserting something that is not accepted here. And this is another huge win for debugging. But again, it's important to stress that type annotations do not prevent your code from running. They just add extra context to our code. So if we were to run this, we would still end up with a value error when we try to insert a and b into this function. Up next, we have habit number 3, which is avoiding mutable defaults at all costs when creating functions. So for this example, I'm going to create a list of integers And then I'm going to create a function that appends an integer to a target list of integers. So here we have the number that we want to append and the target list. And we're going to set the default to an empty list, which is a big no-no in Python. And inside the function, we're just going to append the number to the target and return the target, which will be a list of integers. When we test our function, it's going to look like it works just fine. As you can see, we managed to append 99 to L1. But watch what happens when we create lists using the mutable default. So here, since we don't provide a list, it's going to use the target list as the default. Then we're going to append numbers to L2 and L3. And finally, we're going to print the contents of both of these lists. And as an output, you're going to notice that they share the exact same data, which is quite silly. And this is because Python only creates mutable defaults once when we define our function, meaning that every time we use that mutable default, it points to the same reference each time we use the function. In other words, it only creates this list once when we define the function. So L2 and L3 are using the exact same list. The solution here is to check explicitly whether an argument is none. So instead of setting the default to an empty list, what we're going to do is create a union type using the pipeline operator to create an optional, and then we're going to set it to none. So target of type list or none, which is also known as an optional, will be set to none initially. Of course, that requires us to fix the logic. So here we need to check if target is none, then the target should equal an empty list, a new empty list. And regardless of what happens, we want to append the number that we specify to the target and return the target. And the next time we run this, you're going to notice that both of these lists are now independent. Moving on to habit number 4, which is making your functions as reusable as possible by getting rid of unnecessary dependencies. This makes it far easier to reorganize your codebase later, since each function will work wherever you decide to put it, without having to fix broken code. For this example, we're going to pretend that our script contains a global variable called Mutable, which contains the value of 10. We will then use that variable inside a function. This is fine and works fine. As long as we keep this function in the correct spot, it will work just fine. But now imagine we became adults and decided that having an organized codebase was beneficial for us and our team. So we decided to move this function to a dedicated module. As soon as we move it, we'll realize that it's missing a dependency. Mutable is gone, and we either need to re-import it or create it from scratch. A better solution is to make sure our function is self-contained. And we should have done this from the beginning, but that's not the point here. Here we ensure that our function will work properly no matter where we place it, without having to change any code. Now, a better example might be with a module or a list. Here I'm going to create a list which will contain some names, and what we're going to do next is create a function that appends a new element to this list each time we call it. And once again, we're referring to a global variable inside the function, which means this will work just fine if we call it in the current script. But in doing so, we created an unnecessary dependency for this function. Now this function is tied to this module. A better approach would be to change the function signature to include a target list, and then just append the name to the target. Now to make this work here, we just need to say that we want to append Joe to people, and it will work exactly the same way. And this approach is better because it once again allows us to move this function anywhere without having to modify the code. You could even share this function with your friends, if you have any, and they would be able to run it without wondering where the glob that damn dependency ended up. And finally, we have good habit number 5 for your functions: God clauses. And YouTube is probably going to think this is a religious video due to my accent. But what I'm trying to say is God clauses. When writing functions that perform a lot of checks, we generally have 2 ways of doing it. Of course, there are more, but generally these are the 2 you'd opt in for when you're writing a script. So for this example, we're going to create a function that checks whether a user has a strong password. It's going to take a password of type string, and it's going to return a boolean if it meets all the criteria. Now, I'm not going to write all the logic for it, so I'm just going to simulate that we have some checks that return booleans, such as if the password has 10 characters and has an uppercase character and has symbols, then it's a strong password. But here we're going to use a bunch of if-else checks. So the function is going to end up looking like this. It's going to check first if the password has 10 characters, then whether it has an uppercase character, and finally whether it has any symbols. If it has symbols, an uppercase character, and 10 characters, we're going to return true and that the password is strong enough. Else we're going to return that there are some missing symbols and return false, else that there's a missing uppercase and return false, else that we are missing some characters and return false. So that's the first approach. The second approach is using the guard clause. And here we're doing the exact same thing, except in a different way. So once again, we have all the booleans, and now instead of nesting a bunch of if-else statements, we're doing the opposite. We're checking if not has 10 characters, then it doesn't meet the criteria. If not has uppercase, it doesn't meet the criteria either, and if not has symbols, then it definitely doesn't meet the criteria. So we're putting up a bunch of guards. But if we make it through all of these guards, we're going to return true. Now, the reason I recommend using guard clauses is that it helps with following the logic of your functions. The more you nest if-else statements, the harder they become to modify, not to mention how hard it becomes to keep track of indentation as the code in your function grows. With the guard clause, we don't have to worry about keeping track of indentation. We just need to concentrate on one block of logic at a time. Although, with that being said, this is just general advice. You might handle indentation hell better than others. Anyway, that covers everything that I wanted to talk about in today's video. Do let me know in the comment section down below whether you have any tips of your own that you find useful for creating good functions. Otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.